Okay, before I start the warm-up here, I'm going to do a little bit of recap. From yesterday, we're up to June already. Oh, this is your last month of high school summer.
Oh, thank goodness.
No, just let's go for a whole bunch. I might just.
Oh, yeah. That's a threat. Arrested.
Okay, so from yesterday, let's go over to you guys. For the people that weren't here, can somebody explain what d over dx means? Go ahead.
Derivative of y.
Yeah, so this means, in English, the derivative of y. Someone else other than Chris, what is the derivative of y just equal to? Someone else here, that's please. dy over dx, very good. Let's do one that's a little bit more. So again, when you're taking the derivative, now the nice thing that we learned how to do yesterday, for those that weren't here, Tanner and everybody else, we can take the derivative of variables with two equations. Okay, right? The derivative of x still stays as 1, but if there's a variable other than that, it's d whatever divided by dx. All right, let's just do one more and then we'll get to the question. If I say d by dx of y cubed, okay? We're doing this like a chain rule then. So let's just pretend that was x cubed. What does x cubed change into? Sorry, push your out. Cal, I'm picking on you because you have a beautiful Windsor football shirt on. So go ahead.
3x squared.
3x squared, good. So what's the derivative of y cubed going to be then?
3y squared.
3y squared. With one other addition. We're going to include that dy by dx at the end. Okay, so whenever you take the derivative of something with a y, the dy by dx is just included with it. And that's what we did yesterday, and I got a lot of angry looks and everything else that happened yesterday. But that's the main part of the lesson that I wanted to get from yesterday. Okay, so anytime you take the derivative of y, it just changes to dy by dx. Do you remember, I hope you remember when I started doing derivatives here, I said you can either call it f prime of x or dy by dx. It means the same thing, and that's all we're saying. It's the derivative of that. Okay? Sort of good? Now let's get into our warm-up here. Okay? I'm going to start with somebody at random, that being the best grapher in this class. I called him that this morning, so he's going to start off here. Okay, Matt's going to be up first today. Warm up. See what happens when you're the best at something than Matt? Sorry, not just Matt. There's a lot of people that did really good on that test. So,
I did terrible.
Okay, now we sort of had a question like this one already. Okay, but this is a little bit different. What is the equation of that of? What's the equation of that? Yeah, go ahead.
Circle.
This is a circle, but the idea is instead of centered at 0, 0, it's going to be centered at 0, comma negative 3. Okay, is where it would be, but it's still the same idea. Matt, I would like you to be brave now.
Okay, just do like dx, or
Yeah.
d over dx,
Yeah, now after today we're going to get rid of this, but I'm going to write this down here right now. So we're going to take the derivative of everything here. So all this means for those that weren't here yesterday, okay, it just means you're taking the derivative of each part. So instead of just taking the derivative of the right-hand side, like for y equals, you take the derivative of every single chunk that is in there. Okay? All right, so now, Matt, you're not done yet. Oh, Michael?
Would have thought for anything just made 0.
What's that?
Like normally when you got just a number, you made 0.
And that's the same thing you do. The derivative of numbers, the derivative of x is worth the same, the derivative of numbers work the same. The only thing that's different is for, like, if there's a y or something, okay? So, Mike, I'm going to pick on you since you raised your hand, and thank you. What's the derivative of 100 going to be?
0.
Good. What's the derivative of x squared going to be? Okay, so nothing changes for that. Okay, so everyone see that? Everything works the same. The only thing that's going to change is the y plus 3 squared. Can I get someone who's brave? That's going to be Tori, because you're next anyway. Can you take the derivative of y plus 3 all squared? Go ahead.
dy over dx, bracket 2 times y plus 3. Oh, I was supposed to do like
That's all right?
this,
Yeah,
so,
that's fine.
Bracket 1.
Yeah. Because, now I'm just going to show you why I'm going to do it this way. Not that you're wrong, that's correct, okay? But I'm going to use like a chain rule here, right?
Okay.
So 2 comes down, and then a y plus 3. And then the derivative of the bracket is just d1 or like 1y, so dy by dx is the derivative of y.
Yeah.
Okay, so it's still, your answer's still correct.
Yeah,
Okay.
right.
Whoops, that's a plus to it. Now, for anyone that was or wasn't here yesterday, I'd like, don't answer yet, I want questions, some questions, go ahead.
So the 2x, you brought it down, but then why didn't it just become 2x dy over dx?
Because there's no y's there,
Okay.
right? There's no y's, it'd be like dx over dx.
Oh, right, sorry,
You
I
know
was
what I
like,
mean?
sorry.
X's go with x's, okay? Now, anyone else that wasn't here yesterday, you know, it's a little bit tricky, that's a one for sure. Sorry, for any of the guys in the class that I think embarrassing you guys all three, please don't be embarrassed, I'm sorry. It's out of kindness and love that I give you, that's not out of disrespect, okay, I hope you guys know that. Because I do respect you guys greatly as a class, and sorry that I put you down all year. You guys are the best of the best in this class, remember that always, okay? You really, truly are, okay? Sorry, I'm not good at pep talks, you know this, I'm not good at pep talks.
I feel motivated now.
You do, okay, good. All right, so, anyone that wasn't here yesterday, how are you feeling about this? Tanner, how are you feeling about this? Sort of okay? It's a little bit new, but it's. Well, it didn't. Okay. I'll do this in a long way now. So basically, it's going to be 2y plus 3. Then it's going to be called the derivative of the bracket, right? Right on. So there's no. So the derivative. Guys, stay here, please. The derivative of y we just went over here, just dy over dx. So y. So this was a good question. Then that would be 2y plus 3, 2y dy by dx. Okay. Sorry, yeah. Okay. Does that make sense, or what's going on here? Chris, go ahead.
I have an answer.
No, you're not up. Derek Stanley's up instead. Derek, I'd like you to be brave and tell the class the next step for solving these questions, what we have to do.
Okay, we need to isolate dy by dx.
Now, for those that weren't here yesterday, I just want to make sure you're on the same page here. The whole idea with this question is we want to isolate dy by dx, right? That's the whole thing, find the rate of change. So, Derek, how do you do that, please?
Cancel the 2 and set the x to the other side.
Sounds good. So I'm going to call that y plus 3. Actually, I'll do it in 2 steps, I think. Just not that you guys aren't capable of doing that intellectually, but if I do that, people are going to say, what just happened? Okay, so it's going to be dy by dx equals negative 2x over 2y plus 3, which so dy by dx equals x, negative x over y plus 3.
That's it.
Good. Now, before I continue, can someone tell me what dy by dx means in English? Where's the first derivative? That's the first derivative. What does the first derivative mean in English? Chris, go.
The slope.
This is the slope. Okay, so the slope of the circle So the idea is in this part, you'll get into this more when you get to university calculus too. We just happen to have more inputs here. We have 2 inputs into our equation rather than just subbing in an x. Okay? Are we sort of feeling good before I move on? Okay, I'm going to hit pause. I'm going to find my lesson from yesterday and then we'll begin with my new lesson. Sorry, I
Is it
didn't.
possible to do like more examples like these again?
Near the end. What some of the questions were. Here we go. The title of this note is implicit differentiation again, or part 2 or again. Okay, so this is what's going to happen. For my implicit differentiation again, what's going to happen is I'm going to pick derivatives that are slightly more complicated, Bailey. Okay, product rule, quotient rule, chain rule, and sine and cos. Okay, that's what today's examples are going to deal with. When I'm done with those 4 main examples, I'm going to give you guys time to work, or we can pick questions from that worksheet that I gave you and just do them off there, because that's sort of your homework based on this section, okay? Now, stay with me, please. Don't distract people in the class. That's you I'm talking about. Don't be distracted. Here we go, example 1. guys want to try this one? Or do you want me to just take it through it? You guys want to try it?
I wanna try it.
Okay, I'm gonna give you guys a chance to try it now. Just remember, right-hand side is definitely gonna be product rule, because it's two things multiplied. The two terms are x squared is one term, and y cubed is the second term. If you remember, Callan, I'm sorry, I just happened to be looking at you. You have two things multiplied. We did ones like this yesterday, which was plain x, y. This is gonna be a little bit bigger. Okay, right, but you guys can do this, all right? I hit pause in the video. Just right.